Hi friends, see in light reflection refraction of light we have discussed in part 1 up to mirrors and also mirror formula and finally Snell's law, okay, and laws of refraction also dealt. So only thing left over in the light chapter is lens formula and magnification, convex lens and concave lenses, okay. So in part 2 of light, so this video is the last part of the light one. So in this we'll be discussing about various numerical problems after discussing about the mirror formula, okay. So we already know what is convex lens and concave lens. See, convex lens means you can see it will be in this fashion, concave will be in this fashion. So here you will be having two radius of curvatures R1 and R2. So this one, for this it will be center will be here C1, and for this the center will be this side C2, that is center of curvature. In the same way for concave lens also, second radius R2, center will be this side, and first one center will be this side, okay. This is R1 and this is R2. So two radius of curve, but these will be studying in higher classes +1, +2. In 10th level all these will be not studying, only what is convex focal length and what is concave its focal length, whether it is positive or negative, okay. So in first video I studied about the mirror formula, okay, and also magnification. Now in the second video, convex lens, if you see, observe carefully, see this is the convex lens. In convex lens, already mirrors I told you pole, but here we will be using as optic center. Here we will be using as optic center, please. So that means, for example, when the beam of light is falling, that means when the beam of light is falling, you can see after meeting this one, this is the incident light. This is the incident light, okay. Now after that what happens, it will be falling on the principal focus, okay, and all the light rays will be meeting at a point, you can see. So this is called as focus. All the light rays will be meeting at focus, okay. So that means the focal length, always here also the things will be same thing as mirror. All the distance are measured from the optic center. There all the distance are measured from pole. So here if you observe carefully, the focal length is towards the incident light. That means positive. Focal length is positive for convex lens. Okay? And any of distance are always measured from the optic center. Maximum distance, object distance is negative only. Whereas V only will be changing. If V is coming towards the right side, towards the incident light, it is positive. If V happens to be this side, it will be negative in the case of concave or as well as convex lens. Okay. So this is about the convex lens. Now coming to concave lens, if you observe carefully, see here. See here. In the case of concave lens, see what happens here. When the light is coming parallel, the nature is diverging here, okay. Whatever light you take, parallel light, it diverges. So these rays will not meet, but when you extend the light rays, you can see these will be meeting at here somewhere over. So this is the focus here. That means here the image will be virtual image. Here the image is virtual image. See, you can see dotted lines, and here the image is real, and of course inverted image maximum, okay. So in the case of concave, the image is virtual. You can see the dotted line, that is, and also you can see this is the optic center, and all the distance are measured from the optic center. Already I told you, from the optic center means here if the image is forming this side, we will be negative. If it is forming this side, we will be positive. And object distance always maximum 99%, 100% negative only it is taken, because always it is measured from the optic center. Okay. Right. Now, some important things you have to discuss regarding concave and convex lens. Okay, some important things, that is regarding the ray diagram. Very, very important, please. See here, for example, you can see for convex lens, for example. So this is the optic center. So suppose if the light ray is going, you can see, through the principal focus. Okay. Now what happens when any light ray passing through focus, it has to be going parallel only. Parallel light rays meeting after the lens goes through the focus. If the light is going through the focus, then it has to go parallel. Okay. This is another important thing. In the same way for concave lens, this is the optic center. So if you observe for concave, you can see if the light is going through focus, then what happens after meeting? It will be going parallel. These things you have to remember very carefully. So in the before classes also I told you parallel light always meeting after it goes to the focus. Light going through focus always will go parallel. Opposite, vice versa. Okay. So these things you have to remember very carefully. Light rays going through focus will go parallel after meeting the lens. In the same way, for convex and concave you have dealt. Now the last case in convex and concave, last case. Please note down these figures. These are very, very important. Last case for convex and concave lens. Suppose if the light rays is going through the optic center in both cases. For example, if the light rays is going through the optic center, say, then what happens? There is no deviation, you can show. Okay? The light rays emerge and go inside. In the same way here also. In concave also, if it goes through the optic center, it goes and emerges through the lens. So these are the very important properties regarding convex and concave lenses. If it is go through optic center, light rays, there is no refraction. It goes directly into the lens. It emerges the lens. If it is go to the optic center. Okay. So these two are very, very, very important. Emerge. It will emerge through the without any deviation. No deviation will be there. Okay. So these are the things regarding convex and concave lens. Now we will see about the lens formula and later on power regarding mirrors and also lenses, and after that we will be discussing about numerical problems. Okay. Now first of all we will see about lens formula. Okay. Already we discussed, I will discuss once again. Lens formula. Already in mirrors we discussed. Already in mirrors we discussed about mirror formula. See how to remember also I will tell easily. Mirror formula we have 1 by f is equal to 1 by v plus 1 by u. Magnification minus v by u. Now coming to lenses. In the case of lenses, lens formula, opposite of this one. 1 by f is equal to 1 by v minus 1 by u. Magnification, here minus means here plus, v by u. See, this is how you have to remember the formulas in lenses. In this part 2 video, I am discussing about the remaining part of the light, reflection, refraction. And finally, we will go to the problems. So, in lenses, you have 1 by f is equal to 1 by v minus 1 by. And sometimes there is a shortcut formula also for this one. Suppose if you take this side, then what happens? 1 by f plus 1 by u is equal to 1 by v. If you take LCM, it is uf, u plus f. This is equal to 1 by v. Cross multiply, then you will get V is equal to UF by U plus F. So image distance shortcut formula, you need not take LCM. Directly UF by U plus F. In the same way, if you calculate for this one, what happens? See here. In the same way, if you calculate for mirrors, convex and concave, you take this side, 1 by F minus 1 by U is nothing but 1 by V. Same if you take LCM, UF, U minus F is equal to 1 by V, cross multiply, you will get V is equal to UF by U minus F. These are the shortcut formulas for lenses and mirrors. In mirrors, you will be having, because it is plus is there UF by U minus F, and in lenses because minus is there UF by U plus F. And that is the magnification formula in mirrors, and this is the magnification formula in lenses. Clear? Now let us go to the power of the lens as well as mirror, please. Note it down. Right. Now how to define the power? Okay. Now let us see what is meant by power. See, in general, in lenses or mirrors, power can be defined as, see how fastly the light rays are focused. For example, see here, if you take a concave mirror, this is the pole. Now light is coming, parallel light, and of course this is center and this is focus. So after this, what happens? Light is going to the, whatever parallel light, it has to go to focus. So how fast it is going to the focus, that is called as power. In the same way, if you take lenses also, convex or concave lens, optic center, parallel beam of light going through the focus, you can see, going through the focus. That means how fast the light rays are going through that, whether it is going slowly or fastly, or how effectively. That means, in simple words, power is given by 1 by F in meters in general, because meter inverse is nothing but diopters. This is the SI unit of power in lenses. But here a small difference is there regarding the formula for lenses and mirrors. In case of mirrors, spherical mirrors, power is taken as minus 1 by F in meters. I'll explain. I'll tell you why it is minus. And in lenses it is plus 1 by F in meters. This is in mirrors, please. Spherical mirrors, the power is given by minus 1 by F, and in lenses it is given by 1 by F. I'll tell you why that minus here and why plus here. I'll explain, please. See, generally what happens is, power is treated as positive power for all converging lenses. Here, power is treated as positive for all converging light rays. All converging light rays. See, all converging light rays means what all converging you are having? For example, concave mirror converges the light rays. Okay? In the same way, convex converges. And diverging, all diverging is taken as negative. All diverging light is taken as negative. For example, concave lens is diverging and convex mirror is diverging. So those are taken as negative light rays. That means we'll check the formula whether it is right or wrong for different mirrors and lenses. First of all, I'll take mirrors. For example, concave mirror. For example, I'll take concave mirror. I'll check whether the formula is right or wrong. So what is the formula? P is equal to minus 1 by F in meters, of course, because even in the examination if they are giving in centimeters, please convert into meters only, because diopters unit is got by meter inverse, not centimeter inverse. Meter power minus 1 is taken as 1 diopter, please. Okay. Now we'll check for mirror formula whether it is right or wrong. So that is equal to minus 1 by, first which one you are going? Concave mirror. See, concave mirror, already I told you, this is a concave, and this is the pole, and this is the center, and this is the focus. So you can see here, the focal length is against the incident light. That means negative here. So for concave length, focal length is negative. So minus f. Minus minus gets cancelled, that is equal to 1 by f. Clear here? So power is equal to 1 by f. Clear? So but what is a concave mirror? It is a converging one. But what did I told in the beginning? All converging is taken as power positive. See, you got power positive. Positive power. So it is right. Now let us check the second one, mirror, convex mirror. Second one, convex mirror. Now in the case of convex mirror, if you check it, this is the convex mirror. This is the pole. This is the center, focus. But in this case, you observe the focal length is positive. Radius of curvature is also positive. Let us check the formula. P is equal to minus 1 by f in meters. That is equal to minus 1 by f. That is plus f. And that is equal to minus 1 by f. That means power is negative. And this is what mirror? Convex. Convex is a diverging. What did I tell you? All diverging are negative power. So it's the right one. So like this, the formula you can check. Power for mirrors is minus 1 by f in meters. Lenses is 1 by f in meter. We'll check for lenses also. Now for example, convex lens. See, convex lens is the optic center. Light is, what is happening here? Converging. Okay? So I will check it. P is equal to 1 by f in meters. And also focal length you can see along the incident light. That is positive. So f positive. So therefore you can see the formula, you got a positive power. Just now I told you converging light rays is positive. So this is also right. Now coming to next one. P is equal to 1 by f in meters. Let us go for concave lens. See, in concave lens, if we say this is the optic center, light is coming, diverging. Okay? When you extend, it will be meeting here, focus. So focal length is what? Against the incident light. So negative here. Okay? Negative. Therefore, 1 by minus f in meters. So power here I got it as negative power. What type of lens it is? Diverging. So all diverging negative power. This is also right. So like this you can check up the power formula for lenses and mirrors, please. Please note down. So that is why power I am giving minus 1 by f in meters for mirrors, and lenses it is 1 by f in meters. Depending upon the convergivity or divergivity, the power is positive or negative. All converging light rays is taken as positive and all diverging is taken as negative, please. Clear? Right. Now, almost we came to end of this chapter now. We are given the formula for power also. Lenses also discussed. Okay? Yes. Now, I will be starting now numericals in the light chapter. That is the last part of the story. Okay? Shall we start? Right. First question. Which one of the following materials? See here. First question, please. First question. Which one of the following materials? Which one of the following materials? Which one of the following materials cannot be used? Cannot be used to make a lens. To make a lens. A. Read the question carefully. Water. B. Glass. C. Plastic. And D. Clay. So here he is asking you the question, which of the following materials cannot be used as a lens? See, maximum water also sometimes acts as a lens. Glass also acts as a lens. Plastic also of course acts as a lens. But clay, that means almost mud. So it cannot be acting as a lens. It cannot be act as a lens. Or cannot be used as a lens. You can use this one as a lens, glass, water. So answer will be D, please. Answer will be D. Okay. Next one. The image formed. Next question. the image formed by a concave mirror, the image formed by a concave mirror is observed to be virtual. Virtual, when it's the virtual image, that is behind the mirror, virtual, erect, that means upright, erect, and larger than the object. Larger than the object. So he is asking the question, when it applies, okay, where should be the position of the object? Where should be the object kept, in other words? So if the image found by the concave, you know, this is the concave mirror. Okay, this is the concave mirror. So this is the pole, this is the center, this is the focus F. So already I told in the theoretical points where to keep the object. If you keep the object between focus and pole, between, okay, then you can see the image. One is going parallel and coming like this, another through pole and reflecting. And if you extend these two lines, you can see somewhere over it is meeting. You can see A dash, B dash. So the image you can see very larger, upright and erect. So the answers also is given A, B, C, D. First one is said between principal focus and center of curvature. See, principal focus and center of curvature. This is wrong one. Between C and F is saying. Wrong one. Second one, at the center, is saying at the center C. This is also wrong. Third one, beyond the center of curvature. That means here. Okay? Beyond. Beyond C. This is also wrong one. Now last one, between pole of the mirror and principal axis. You can see between the pole and principal axis. This is correct one. Between P and F. So then only you can see the image is a virtual, erect and of course little magnified. That is the second one, please. Let us go to third one. See, are you noting down? Okay. Now third question, please. A spherical mirror and a thin spherical lens each has a focal length of -15. See here, next third question. A spherical mirror, that may be convex or concave, and a thin spherical lens and a thin spherical lens have each a focal length, that means both the focal length is same, of -15 cm. The mirror and a lens are likely to be, the mirror and a lens are likely to be dash A, B, C, D. I'll rub this one for better. Meanwhile, you try the question. Okay, I'm rubbing this one. Next question, please. Okay. So please, if you study concept only, light problems you can do, otherwise you cannot. Now what is this fellow saying? He has given the choice also. Both concave, A is saying both concave. Both concave, A answer is saying. B is both convex. B is saying both convex. Okay. He's asking if the mirror and lens are both concave, both convex. The mirror is concave, lens is convex. Mirror is concave and lens is convex. And here I think last will be reverse. Mirror is convex and a lens is concave. So these are the things given. Mirror is convex and lens is concave. Now how to get this one? See, saying a spherical mirror and a thin spherical lens has a focal length. How much? Minus 15 centimeters. So for this, what we know, already we know power is equal to, okay, power is equal to 1 by F. And we have the formula, both you can apply and check it, because spherical mirror and lens is same. Already power for mirrors, what I have given? Power for mirrors is 1 by F in meters, and power for lenses, just now I told you, power for lenses is 1 by F in meters. So these are regular formulas, these are for mirrors, and we'll check one by one. So power for mirror is equal to minus 1 by F in meters. That fellow is given in centimeters, focal length, minus 15. So minus 15 means convert into this thing, 15 by 100. Because it's given in centimeter, 0.15. So 100 will go to top, minus cancel. 100 by 15. 5 20s are, 5 3s are 15. 3 6s are 18. Okay, 2 is there, 0.66. Okay, and please make a note, it is in meters, because I converted into, I told you beginning, even if you give centimeters, to convert it into meters, please. So therefore, power of the mirror, I got it as positive value. So when the power is positive, if the whatever mirror is converging one, converging means which is converging, concave or convex? Convex is diverging. So this will be concave mirror, please. Concave mirror. You can check first one. Concave mirror. Mirror is concave. One I got the answer. Next, check for lens. Power of the lens formula is 1 by F in meters. Okay. So he has given what again? Minus 15. Okay. So each is having focal length. Yes, write the value first of all. Minus 15 means that is minus 1 by 15 by 100, convert it. That means minus 100 by 15. Are you following here the point? Here the formula for lenses is 1 by F. Mirror is minus 1 by F. Okay, just a minute. Here minus 1 by F, minus both I kept it here, both are cancelled. Yes, both are cancelled. Yes, we got positive value, and power is positive means which mirror it is? Concave mirror. Okay. Now observe carefully here. The power formula for lens is 1 by F in meters. That means 1 by F. F is given as minus value. So 1 by F. That means finally you got how much? 5 20s are, 5 3s are. That is minus 6 point. 6 are 18 2. 6.66. Okay. And this value, please see here carefully. You have written meters here, power this one, not meters, please. It is diopters. So here also diopters. Here I got negative value of the power, minus. So when the power is negative for diverging lens. So convex is a converging lens, concave is a diverging lens. So this lens should be concave lens because power is negative you got. That means mirror is concave mirror and lens is concave. So both are concave. See here, A. Okay, both are concave. A is the right answer. Did you get the point here? So mirror is a converging one, positive, concave mirror, and you got negative value. When the negativity is, all diverging powers are negative. So because you got minus 6.66, power is negative means it has to be diverging. So certainly it is nothing but concave lens. So concave lens means both are concave. So this is the right answer. Both are concave. Clear? So like this you have to justify the answers. So how many questions? 3. Okay. Now fourth one. I am marking this one. Let's know, I think I completed third question. Fourth one. 1, 2, 3. Fourth question now. Fourth is complete, isn't it? 1, 2, 3. Third question is completed. Now fourth one please. 1, 2, 3. Now fourth one. Okay. So shall we go to the next question now? Okay. Now we will go to some more problems. Let us solve some important questions now. So this is the last part of the video in our light chapter. Next one, what is the unit of power? Fourth one, what is the unit of power in mirrors or lenses, please? A, B, C, D. First one is given as newtons. Next one joules, B. C, meter inverse or diopters. D, none. So already I told you this concept. The unit of power in lenses or mirror is either meter inverse or diopter. C is the answer. Fifth question. Okay. Power formula for mirrors is dash. Power formula for mirrors is dash. A. Already this was also discussed in the class, the before video. Okay, he has given some choice also. P is equal to minus 1 by F in meters. B. P is equal to 1 by F in meters. C. F in meters. D. None. I told you regarding the mirrors and lenses separately. For lenses and for all converging, power is positive, and for all diverging, power is negative. But power for mirrors is minus 1 by F in meters. So A will be the answer, please. You have checked also that one. Sixth question. What is the mirror formula for, what is the, okay, next one. What is the formula for, yes, okay, write down this one. What is the, next question also, same thing. What is the power formula for lenses, please? A. P is equal to minus 1 by F in meters. B. P is equal to 1 by F in meters. C. F in meters. D. None. So here also I told you regarding lenses, P is equal to 1 by F. 1 by F in B is the answer. Okay. Now seventh one. Please note down. These are little twisting questions, theoretical part. After these questions, we will do some numericals also, little tougher problems than this one. Okay. Now let us go to seventh question, please. What is the mirror formula? Seventh one. What is the mirror formula? A. Choice is given. 1 by F is equal to 1 by V minus 1 by U. B is given by 1 by F is equal to 1 by V plus 1 by U. C is given by 1 by F is equal to R, and D is given by none. So already told you in mirror cases, mirror formula is plus, magnification is negative. Okay, but here you can say B will be the right answer. Mirror is plus formula, magnification negative. Whereas in lenses, here negative, there positive. Eighth question. What is the lens formula? Yes, coming one by one questions. What is the lens formula? What is the lens formula? A 1 by f is equal to 1 by v plus 1 by u. B 1 by f is equal to 1 by v minus 1 by u. C 1 by f is equal to r, and D none. So this also we discussed. Lens formula is reverse of mirror formula. So B is the answer, please. B 1 by f is equal to 1 by v minus 1 by u. So that is the 8th question, please. Let us go to the next one now. 9th question. 9th one. 9th question, please. What is the magnification formula in mirror? What is the magnification formula in mirrors? Dash A, B, C, D. So he is asking you what is the magnification formula in mirrors. A V by U, B minus V by U, C U by V minus, and D none. So in mirror formula magnification, one is plus, another is minus, I told you. So certainly M is equal to minus V by U. B answer. Okay. 10th one. 10th one, please. Okay. Let us see this question now. Next one. Next one. What is the magnification formula for lenses? What is the magnification formula for lenses? Dash A, B, C, D. V by U minus V by U minus U by V, D none. I told you in lens formula 1 by F is 1 by V minus 1 by U, and magnification is plus. So A will be the right answer, V by U. Okay. So these are, even though looks very easy, sometimes it becomes very tough. Now let us go to the 11th one. 11th question. 11th one, please. 11th question, you can see here. Calculate the power of 11th one, please. Calculate the power. Calculate the power of A concave lens of focal length f is equal to 2 meters. Okay, A, B, C, D is given as answers 0.4, 0.5, 0.2, 0.1. All are in diopters, please. All are in diopters. All are in diopters. So solution is in this. Already I given the formula. For lenses I told you power is equal to what? 1 by F in meters. Okay. Power is given by, for lenses. For mirrors it is minus 1 by F. Therefore 1 by focal length 1 by 2 in meters, that is 0.5 diopters. So B is the answer. So B is the answer. B is the answer. Okay. Now let us go to 12th question, please. So be careful regarding the formula. For mirrors it is minus 1 by F in meters power, and for lenses it is 1 by F, please. Okay. Now in 12th question you can see a little twisting question this is. He has given a question like this. A convex lens, you can see here, a convex lens of focal length 10 centimeters. Okay. Now what he is saying is, an object is placed at 15 centimeters from the optic center, 15 centimeter from the optic center. Height of the object is height of the object is 2 cm. Okay. Now he is asking you calculate V comma M. That means image distance and magnification. Is given answers A, B, C, D. Some answers he has given minus 30 comma minus 2, plus 30 comma minus 2, minus 20 comma minus 2, plus 20 comma plus 2. Now let us try this problem. It is twisting problem. You have to use some formulas. Convex lens here, a convex lens of focal length. See, I told you in the beginning, convex lens means this is the optic center. Light will be coming, going like this to focus. So here the focal length is positive place. That means how much? Plus 10 centimeters. Object is placed at 15 centimeters. So object is placed at 15 centimeters. U is equal to 15, that is minus 15 from the optic center. And the height of the object is given HO as 2 cm. Now he is asking you what is the V and M. So we already have a lens formula. 1 by F is equal to 1 by V minus 1 by U. So we will get V, take this one to this side. The formula goes like this, shortcut. UF by U plus F. If you take this side, both will be plus. So UF by U plus F. U is minus. What type of U? Minus F, focal length positive, plus by U minus F. Minus 15 minus 10. That is minus 150 by minus 25. Minus minus cancel. 25 6. Is that right? Is that right? Okay. So V I got according to the given data, this one. According to the given data, I got V is equal to that value. Okay. So here object distance is given. Sorry, here object distance is given. No. Yes, of course, if you take this side, 1 by U. LCM UF by U plus F. U minus 15. F focal length positive by U minus F. That means minus 15 minus 10 minus 25. Yes, we got plus 6 value V. We got it as plus 6 value. That means along the incident light, somewhere over here. Okay. So answers, I think they are given wrong answers. Let me check up. We got this thing. And what is magnification for lens formula? Here minus means there plus. V by U, that is with the sign. Plus 6 by U minus 15. 3 2s are 3 5s are. 3 2s are 3 5s are. That is 2 by 5. Minus 2, that means minus 0.4. That means answers are plus 6 comma minus 0.4. This data is wrong, data is given here. You have to correct the answers. Correct the answers, please. Okay. So correct the answers here. We got my plus 6 minus. That means one will be plus 6 minus 0.4 minus 6 minus 0.4. Okay. Plus 5 0.4 minus 5 minus 0.4. So we got plus 6 minus 0.4. So this is the value of V and magnitude. See, you have to be very careful. Sometimes if data is not given properly, you have to check up by solution, please. That is the 12th problem. Now let us go faster with the next 13th problem. 13th. Let us go to 13th question. So have you copied this one? So this is how you have to go in shortcut method, direct formulas. 13th question, please. 13th question. Now in 13th question, if you observe carefully, 13th one. So he is given as, see here, a concave lens. A concave lens has a focal length of 15 cm, it seems. Okay. and image is formed at 15 centimeters. 15 centimeters. Image is formed, so not 15, 10 centimeters. Image is formed at 10 centimeters from the lens. Image is formed at 10 centimeters from the lens. Calculate U, comma M. So object distance and magnification is asking. Okay, calculate U and M. Let us try this question. Okay, let us try this 13th question. Very interesting one. So here is given as concave lens, please. So he is given answers also. I think A, B, C, D. You can try. The answers is given as. Note on the answers also, please. 30, plus 30, minus 0.3, minus 30, plus 0.33, 40, minus 0.3, minus 40, plus 0.33. Okay, so these are the things as given. Let us try this one solution. Concave lens. See, this is a concave lens. Let us try to draw the figure. Optic center. Focal length is given, because focal length for concave is negative, of course. F is equal to minus 15 centimeters. V 10 centimeters from the lens image. Generally image is formed as virtual only here. So V is equal to minus 15 from the lens. Okay. Calculate U. So you have to calculate the object distance here. How much? So you have to go for the formula 1 by F is equal to 1 by V minus 1 by U. 1 by minus, focal length is negative now. So 1 by F means 1 by minus 15 is equal to 1 by V. V is given 10 cent, that is 1 by V, that is minus 10, please, because from the optic center negative value, minus 1 by U, take this side 1 by U, plus take this one to the other side, so minus 1 by 10 plus 1 by 15, LCM 150, minus 15 plus 10, that is equal to minus 5 by 150. Please check up, please. So finally 5 ones are, 5 30s are, and finally you got it as minus 30. That means the object is placed from the optic center at 30 centimeters from the optic. That is why you got minus 30. So minus 30, I think here minus 30 is there, object distance. And one more he has asked magnification. Magnification is V by U for lenses, because this is minus, with proper sign. V already we got how much? Minus 15 by minus 30. Minus means cancel. 15 ones are 15, 2 are 0.5 plus. 0.5 plus, if that values are right. Please check up V, how much we got? V by U, that is minus 15 by U, minus 30, yes, 0.5 only. So I think their answers is not given correct one. Yes, I think not 0.33, it is 0.5, please. Plus 0.5, please. Okay. So B will be the right answer. You can check up. Magnification means, here minus means it is plus, no, V by U, with proper sign. With proper sign conventions. Okay. So V is how much you got? Minus 15, isn't it? Like from the minus 15 by minus 30. Yes, 15, yes. So this is how you have to solve. Okay, clear? So those are the answers. Let us go to the 14th problem, please. 14th problem. Let us go to 14th problem. These are very, very, very important. 14th. Okay. Now, 14th one. What is the least distance of distinct vision? What is the least distance of distinct vision dash centimeters. A, B, C, D. 20. That means for normal person, please, for normal person without any sight. Okay. What is the least distance of normal person means 20 is given, 25, 30, 35. So generally 25 centimeters. B will be the answer. Least distance of distinct vision is 25 centimeters maximum for a normal person. Okay. Next one. 15th question, please. 15th question. I'll rub on the top. Fifteenth question, please. See here, all of you. 15th question here is giving you. See here, please. 15th question. Yes. 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 The formula for refractive index is dash A, B, C, D. Okay. A, sin I by sin R, sin R by sin I. Okay. V by C, D is none. Suppose if it is C by V, this is also right for mu, but it is V by C, it is wrong one. And this R by sin R by sin I is again wrong one, because sin I is sin R is right one, because it's Snell's law. So refractive index mu is given by sin I by sin I. This is also called as Snell's law. In refraction I told all these things. 16th question. 16th question, please. Write down. If C is equal to 3 into 10 power 8 meters per second, and which is called as velocity of light in vacuum, air or vacuum. Okay, and in a medium, the speed is given as, the speed is given as 2 into 10 power 8. 2 into 10 power 8 meters. Calculate refractive index mu value. Okay, is given choice also A, B, C, D. 1.4, 1.2, 1.5 and D is none. So let us see this one. Let us calculate. Okay. See here. Already I told you refractive index mu or n is given by C by V. Velocity of light in vacuum by in medium. So that is equal to 3 into 10 power 8 meters per second by V. Medium how much is given? 2 into 10 power 8 meters per second. Meters per second, meter per 10 power 8, 10 power 8, 3 by 2. That is 1.5. C is the answer. Okay. So like that you have to go a little faster to get and save the time, please. Please copy it. 16th one. Okay. Very, very important, please. Next. Next, another important one. 17th one. 17th one. The relation between radius of curvature and focal length is given by dash A, B, C, D. F is equal to 2R, R is equal to 2F, R is equal to F by 2, none. Already this also I told you in the concept base. Relation between maximum in lower classes, it is taught as R is equal to 2F up to 10th level. But in higher classes, it may not be equal to 2F. Slightly difference will be there. Okay. So radius of curve is 2 times the focal length, or R by 2 is equal to F, not F by 2. R by 2 is equal to F. So this one also is right answer, but I will change this one. Okay. R is equal to 2F. R is equal to 2F. Yes. I have to write the answer also, right? R is equal to 2F. So these are the given things here. F is equal to 2R is a wrong answer. 2R, F, that is also wrong one. R is equal to 2F, or R by 2 is equal to F. 2 times focal length, radius of curve. This is the right answer. The relation between radius of curvature and focal length, please. That is 17th one, please. Writing? Okay. Let us go to the 18th problem. Let us go to 18th. Try another interesting one. Okay. Now we are saying so almost 17 problems we have done, I think. Okay. Yes. 18th one. What is the value of refractive index of water? A 3 by 2, B 1, C 4 by 3, D none. In general, water is taken as 4 by 3, that is 1.33. Okay, and 3 by 2 is not water. 3 by 2, 1.5 is the refractive index of glass, please. Okay, next. Nineteenth one. When a light ray okay, comes from denser medium to rarer medium, then it goes dash A towards the normal, B away from the normal, C along the normal, and D is none. See, already in the concept I told you regarding the optically denser, which is having more denser refractive index, there it goes towards, which is having less denser, it goes away. So when a light ray is coming from the denser to rarer, that means heavier to lighter, so it goes away certainly because it is less optically denser. So you can see B is the answer, goes away from the normal. Towards the normal means rarer to denser. Okay. So like this you have to justify your answers. This is a 19th question. One more I will discuss so that it will become a figure 20. Okay. Clear? Copied? Yes. Last one, 20th question. This will be the end of the light chapter, part 1 and part 2 finally. Yes. Last question. Yes. 20th question. The power of a lens is given as 3 diopters. the power of the lens is given as 3 diopters. Calculate the focal length. Power of the lens is 3D. Calculate the focal length. A, B, C, D. Power of the lens is given as 3 diopters. Calculate the focal length. A 0.44, 0.33, 0.11, none. See, already I told you regarding the power, how to solve the problems. Okay. Power is given by lenses 1 by f in meters, whereas in mirrors it is minus 1 by f. Therefore, power already is given as 3 diopters. 3 is equal to 1 by f in meters, or cross multiply. Focal length is equal to 1 by 3, that is 0.0393, 0.33. So B is the answer. Focal length in meters, of course, okay, because it is in diopters. 0.33 meters. See, these are some examination problems regarding Polycet 2025 from light, reflection and refraction of light. Okay, again we'll be meeting on in the next and last chapter, next video, that is human eye and colorful world. Okay, right.